Welcome to Out of the Lab, a podcast interviewing entrepreneurs who've taken research out of the lab and built it into a company that's serving the world. These entrepreneurs are heroes, and the planet needs more of them. So tune in, learn from their successes and failures, and get inspired. Visit bountiful.org to join our community and realize your power to save the world. My conversation today is with Alex Wright-Gladstein, founder of Ayar Labs, a university spinoff that is basically moving data using light and reducing the energy footprint of data centers. So they're leading the next iteration of Moore's Law. And this conversation today was absolutely incredible. I loved it. I learned a ton from Alex about the early days of forming a university spinoff. So we dove into the beginning of her journey where, as a student at MIT, she was knocking on professors' doors in labs and just asking for technology she could work with to form a business. She quickly learned that that really wasn't the best way to go about it. And so we talk about tips for applying the SBIR, that's Small Business Innovation Research Grants, a hugely valuable lever for non-dilutive funding for many of you in the US, and so many more details of what's involved in the early days. This episode is absolutely a must listen for anyone looking to turn a piece of research into a fully commercialized startup. So sit back, relax, and enjoy. Alex, thanks for joining us.
Thanks for having me, Max.
So in 2013, did you just finish an MBA at MIT?
I was actually just starting an MBA at MIT.
Starting an MBA at MIT, and you were looking for a technology to have impact in the climate space that you were looking to build a business out of. Can you talk about sort of why you were looking for something in that field and how you were looking in that time?
Yeah, I guess for me, it goes all the way back to my 7th grade science teacher who got me inspired about environmentalism and kind of throughout the rest of school and university. That kind of coalesced into really caring about climate change and being worried about the climate crisis from a pretty young age. And it took me a while to figure out what I wanted to do to have an impact in the climate space, but I realized that if I could help get innovative technologies out into the world that could have an impact, that would be a worthwhile role for me to play. So I decided to attend MIT for an MBA in 2013, really as kind of an excuse/cover story for spending a lot of time on the MIT campus and getting to know people across campus who were inventing technologies that could have an impact on climate.
So at a super young age, you said, I need to help get technology out of the lab and into the world.
No, super young age, I just realized climate change is scary and I should try to do something about that. And it wasn't until really the end of college, so in my early 20s, that I realized, hey, the role I could play is helping get technologies out into the world. Because I realized, you could read in Popular Science and these other magazines about this incredible technology that's going to save the world all the time. But most of the time you read about that technology and then you never end up being able to buy it. And I was wondering what happens from when these incredible things get invented to them not actually making it out into the world. And why is that? And can I have a role there?
That is an excellent question. I just as a tangent, I mean, have you arrived at the answer to that in a very concise sentence or two?
Oh, well, I think it's different for every technology, but I think one thing that is definitely a systemic thing that's going on is that the people who invent technologies tend to be people with PhDs in engineering or science who have spent their entire lives up to that point coming up with this incredible innovation. And because they've been so focused on their research for years and years and years, oftentimes by the time they have that success, they haven't developed the skills for entrepreneurship. They just haven't had the time in their days, right? It's taken all of their time to create the technology. So it's this unfamiliarity with the entrepreneurial process that is a hindrance to the engineers and scientists who are actually inventing technologies to take that leap and become entrepreneurs. And then, you know, it's also just that the business world it tends to be pretty separate from the world of research. And you know, you feel it really at any campus you go to. If there's a business school and then an engineering school, oftentimes there's not much intermingling between the two. So, you know, even if there could be, you know, people coming along and saying, hey, I want to help you commercialize this technology, oftentimes there's mistrust between, you know, business people versus technical people. It's hard to kind of develop that level of trust where an inventor would feel comfortable partnering with a business person to start a company. So I think it comes down to those two things: technology people, inventors oftentimes not having the entrepreneurial experience or skill set, and then the entrepreneurs who come from business backgrounds oftentimes having trouble building up a level of trust with inventors to be able to partner with them and take, you know, this baby, which is their invention they've been working on for years, and create a business with it.
Cool. Well, we'll get back to some of the remedies a little later, but I want to go back in time, I guess, to 2013 when you started your MBA. So you wanted to expressly be hanging out on MIT's campus. Just curious, is there any reason why MIT, the preeminent sort of technology institution of our day, or close to home?
Well, so I am a California native, and I actually, when I first realized that this could be a way for me to have impact, I was living in San Francisco, and I had found out about a class at UC Berkeley called Cleantech to Market. And I thought, oh my gosh, that's exactly what I want to do. It's a class that takes groups of students and puts them on a project working on technologies, clean tech technologies out of labs, and works on commercialization plans for them across the semester. So I decided to apply for an MBA at Berkeley. And then I thought, okay, I should probably apply to a couple other places too, just in case I don't get in. And I started paying attention to what other MBA programs are at universities that have a lot of clean tech research going on, and realized MIT does. Went to visit MIT and then realized that not only did it have a class that's pretty much the same as Clean Tech to Market, there it's called Energy Ventures, but it also had another class called Innovation Teams, and it had just basically, it was kind of like the Clean Tech to Market class on steroids. There were so many classes about innovation and commercializing technologies in the MBA program at MIT, and I realized, oh my goodness, I should probably be paying more attention to MIT than Berkeley, because it seems like there might be even more opportunities for commercializing clean tech there. So I of course applied to both, and I ended up deciding to go to MIT.
Cool. So you're doing an MBA and you say, okay, I'm on campus, the search begins. I mean, can you tell me, I guess, how you started searching and maybe how you adapted and what you learned in the process?
Sure. Yeah. I would say before getting the MBA, I had this idea that I would love to help get technologies out of labs. And I had tried to figure out how to do that by looking at patents coming out of technology licensing offices at universities, and realized at some point that it's hard to just take a patent and commercialize a technology without having the person who invented it at your side. Who really knows how the technology works and can make sure that the product you make actually works. And so by the time I arrived at MIT, I was on a mission to get to know inventors, not just find technologies. And I was extremely awkward at trying to get to know inventors at first. I had a few professors that I really was very excited about when I arrived, because I'd been reading their papers and just the things they had been inventing were really incredible. And I literally just went and knocked on their lab doors and introduced myself awkwardly and said, hey, I'm an MBA student and I'm wondering if you could use any help in thinking about commercial applications of your technologies. And, one of them actually said, sure. And I did work with, she kind of paired me up with one of her grad students, and I helped him do a little bit of background research to kind of put some context in a paper that he was writing. But it was definitely a little bit of an awkward way to approach the relationship. And so fast forward to these, when you first arrive at an MBA program, you typically have to take these core classes. So you have no choice in what classes you take for the first semester, and that's true at MIT. So fast forward to when I started having choice in classes, and I got to take this energy ventures. Well, first I took the innovation teams or I-teams class, and I worked on a material science technology that was really exciting.
As part of the coursework.
As part of the coursework, but actually, so that was the spring of my first year, and got to know everyone in the lab really well. We had a team in the class that was working on commercial applications of this technology. And, throughout the class, I got to know the various grad students in the lab working on the technology. And over the summer, I stayed in the Boston area and kept working with them to see if there was commercial traction for this idea. We ended up realizing that, this material they had invented was, because they were making it in such tiny quantities at the time, there was going to be a big scaling up of production challenge that probably should take place in a university setting, in a lab, as opposed to a commercial setting for the next few years. So it was a little too early to commercialize it. But it was a very valuable learning experience for me to kind of learn how to assess a technology in that way. I hadn't even thought to ask that question of, how long will it take to be able to make substantial quantities of this thing, until months and months after working with this group. The idea was to find a better method for scaling the technology in the lab setting that could then be commercialized. Like the method that was developed at that time was insufficient for scaling. They had figured out how to make this really cool material, but they could only make a few molecules at a time. And so it was tough to find a commercial application where you wouldn't need more than a few molecules at a time, basically. And so they had a lot of great ideas for how to scale up the manufacturing of that to larger quantities. But testing those out and getting to the higher volumes would probably take a few years, and was something that probably should use government grants for funding rather than, commercial VC investment. So it was just a little bit too early, but it was a really valuable learning experience for me to get a better handle on how to assess technology for commercial readiness. Wow, very cool. So then towards the end of that summer, I ended up being the TA type person for that energy ventures class that I mentioned before, which was amazing because I got a list of 300 labs at MIT that do energy related research, which was incredible to me because I didn't even know there were 300 labs at MIT, let alone 300 that just do energy related research. So it was kind of like the perfect list of exactly what I had been looking for. And I emailed all of them and I told them, there's this energy ventures class and we're looking for technologies that are close to commercial readiness, where we would put a group of students on the technology for a semester and come up with commercial applications and a business plan. And a lot of the 300 labs had technology that wasn't close enough to commercial readiness to make sense. There were about 20 or so that were later stage, and about a dozen were a good fit for the energy ventures class. Did you, I assume not all 300 even answered. Were you following up? Did you go to any of the labs in person? Or only? I was following up. Yeah. A lot of them didn't answer, but I did try to follow up. I ended up meeting with maybe 20 to 30 in person. Cool. And then of those, about 12 were a good fit for the class. And then I took the class. So, I told the professor I didn't want to be the TA during the semester because I wanted to be a student working on a technology in the class. And so I went from being the TA type person to then being a student in the class, and I got to pick the technology I was most excited about out of the dozen to work on, which turned into Ayar Labs. So we formed a team. There were 6 of us, which is a bigger team than average, to work on the commercialization of the technology. I think there was some signaling there that the person finding the technologies over the summer was most excited about this technology. So there were a lot of people who wanted to work on this one in particular as a result.
So, and how did you assess that? Like, so these are 6 of your peers that wanted to join, and how did you settle, I guess, on this technology?
Yeah, so there were a lot of really incredible technologies going into the class. So it was hard to choose, but I had 2 criteria. One was, what is the climate impact that this technology can have? And the second was, how much do I like the PI? Do they seem like a nice person who would attract other nice people to work with them in their lab? And you know, could I see myself having a long-term working relationship? It's kind of like a marriage, right?
Right. The PI, for anybody listening, is the primary investigator or the researcher, essentially.
Yeah, the principal investigator. Thank you for pausing and saying that. And that is basically another term. It's the term most frequently used by researchers in labs to refer to the professor who heads up that lab. And they typically run an entire organization. It could range from just a handful, or maybe just 2 or 3 grad students if they're new at the university, all the way to very large organizations. It's kind of like their own little business or organization that they're running that has PhDs, master's students, undergrads, all doing research, as well as postdoctoral researchers, all in their lab.
Well, so. and they yield quite a lot of technology. Like, I don't know how many of our listeners have ever done this, but if you go to, they a lot of the bigger ones even have websites where they list all of the technology and all of the people working in their lab, and it can be, quite robust. And so one of those technologies you're going to work directly with the PI on. I mean, is it not also a scenario where you would work with the grad student, like, but getting
I should also say, yeah, like they're also like superstars. They're, each PI is incredibly busy, has its whole organization under them, and is very, very, very well respected within the university ecosystem and within the, the broader ecosystem of whatever their research topic is. They've done a lot to earn getting to where they are. And so it is hard to get their attention and to get time from them because they tend to be incredibly busy.
But nonetheless, getting to know them, making sure you like them is a critical step, or what was one of your criteria, which I don't know if you did this again today, would that still remain part of the criteria?
Absolutely. And you're right that, I forget what exactly you were asking before I kind of interrupted you just now, but you were starting to ask about the grad students and whether I worked closely with them. And you're absolutely right. It's typically the grad students and postdocs who are doing the on the ground research work. And it tends to be the PIs are providing the vision and the guidance. They're mentors and advisors to these grad students. But as far as the ones actually putting together whatever the invention is, it's really usually the grad students and postdocs doing that. So to me, it was very important to get to know the grad students and postdocs and figure out which were the ones that were kind of key to inventing the technology. Right. So they were the ones to start a company. They're the ones who actually know how to build the thing because they have been doing it.
Right, and it's conceivable. It's conceivable that person might come and work in your company. Like if they are less tied to the university, they have less tenure, they are maybe a potential, I don't know, CTO or something like that to help lead the technology forward, right?
That's exactly right.
And is that what happened in Ayar Labs?
It is. That's exactly what happened in Ayar Labs. And I can give you some details if you want.
Yeah, I love details. But so 6 of the people in your class started, like I'm very curious in the minutia of all of this. So 6 of the people in your class started looking into this technology, and yeah, I guess take us forward from there.
Yeah, so there were 6 of us. They create these interdisciplinary teams in the Energy Ventures class. So we were actually 3 MBAs. which was a little bit more than the average. But like I said, there is so much demand for this technology that the professors just allowed the team to be bigger than it usually is. And then there was a policy person and 2 engineers, but the engineers were not from this lab. You know, the idea was for them to bring general technical knowledge, but they weren't the inventors. So the team of the 6 of us started having lots of conversations with both folks in the lab to learn more about the technology. And this is where we started meeting the PhD students and postdocs working on the technology, as well as with industry, trying to learn, okay, what could the practical application of this technology be? And at this point, oh, go ahead.
No, I love this. So, you know, when you looked at the technology, I mean, had the PI already sort of identified the specific application, and that was one of the ways that you assessed criterion number 1 was that it would have this big climate impact? It was, you know, they had already kind of, upon inventing it, thought about the potential application and the potential impact that it might have?
They had definitely thought a lot about the impact, the kind of broad vision of this technology. You know, this is why they had been working on it for a decade. And by the way, the PI in this case, his name is Rajiv Ram. And he's still at MIT, and he's also a co-founder of Ayar Labs, a part-time co-founder. So when he first told me about this technology, he definitely had a very compelling way of describing it.
And its
you know,
potential.
they hadn't,
yeah,
and its potential. You know, they had not yet made the world's first processor to communicate using light, but they had just designed it and sent it out for manufacturing. And in the semiconductor world, it takes, especially when you're a university lab and you don't have high priority in the manufacturing facilities of semiconductor chips where you can outsource manufacturing, it takes a very long time from when you send out your design to when you get it back. So they had sent out the design, or they were in the process of being about to, and hadn't gotten it back yet, didn't know if it would work, but they had gotten a lot of other chips back that had been kind of things they had been working on along the way. And they knew that this was a promising technology where for the first time it might be possible to have optical communications from the very same chip where you can make a processor, which until then had been thought to be impossible. And so he did paint a pretty exciting picture for me of what having optical devices and optical communications on the same chips as electrical functionality, such as an entire processor, of the practical implications that would have. You know, I can't remember the exact terminology he used, but I did have a pretty good understanding that this could enable a fundamental re-architecture of how computers are made and how data centers are made to create much more efficiency in how they're designed, especially in this era of big data where we're moving so much data around, and electrical interconnects are a bottleneck, making it really hard to move data around in these supercomputers and data centers that are using electrical interconnects today. So he did paint a pretty good picture of how this kind of fundamental ability on a chip could enable a total re-architecture of a data center that could make it much more energy efficient.
right.
And also that overall performance of the computer would increase. So I liked that, you know, this enables a complete re-architecture of the machine, makes it much more energy efficient, but also it makes it a more powerful computer. Because my own background, prior to getting an MBA, I had worked in energy efficiency and smart grids. And in that world, when you're selling your product to customers, you're selling it based on a payback time. It's kind of like solar panels, you know, pay up front was the pitch way back when. Now there are other models, but you know, the original pitch was pay up front for this thing, whether it's better energy efficiency for your facility or solar panels or whatever. And in 2 or 3 or 5 years, you'll get your money back based on the energy savings you have, and then you'll start making money. It's a hard pitch to make as a salesperson. If you could just make the pitch instead of saying, hey, for your data center, you know, adopt this technology, and in 3 to 5 years, you'll save enough energy on your data center to make it worthwhile. and then you'll start making money. Instead here, the pitch could just be, hey, adopt this technology and your computer will run way faster. And by the way, you'll save energy too. I loved that idea of that pitch. So those were two things I liked. I also did a little bit of research on data centers and how much of global energy use they use. You know, how impactful can this be if really what all you're targeting is computing and data centers? And I learned that while compute is a small, at the time it was a small overall user of energy worldwide, I think around 2%. It was the fastest growing user of electricity worldwide. It was projected to reach 10% of electricity use by 2020. I don't know if that's come true, actually. I've tried to look a little bit to see whether that's come true, and I haven't found hard numbers on that now that we're past 2020, but I'm curious as to whether it did come true. And regardless, the theme is there that it's growing incredibly quickly, and that growth is key to me. Any industry you want to create change in, you want it to be an industry that's growing or has some dynamism or change going on, because that's when it's easier for new entrants to come in and make a change. So all of those things got me excited about this technology at the time.
That's excellent. And so you assessed all of this in that time as an MBA student in 2013.
2014, in that summer before taking the class. And I remember I had, a few weeks leading up to the class starting and having to choose one of these technologies. And I was just like, oh my gosh, I hope I pick right. I feel like I'm ready now. I'd already worked on a couple of different, potential business ideas in the prior year. Neither one had worked out. I felt like I'd learned a lot. And I thought, oh, I hope I can pick the right one this time in the Energy Ventures class. And
wow.
So I picked this one.
I wonder where the other technologies that you didn't choose have ended up. It's quite possible that they're still maybe sitting on the shelf at MIT, right? Available for license.
Yes, very possible.
So there are a couple, the silver and bronze medal might also be as compelling as Ayar Labs someday, if anyone wants to go look and try to license those.
Yeah, and I wouldn't call them silver and bronze medal by any means. I mean, I think they could each have huge impact, and it's really a question of timing.
Do you remember what they were?
Of course. So the one I worked on immediately prior was this material that it's a chemical that when light hits it, it changes form and it stores energy basically in this different shape of this molecule basically. And then you can trigger it to release that energy in the form of heat. So just kind of an innovative material that you could think of all kinds of things to do with, coating, whether it be clothing or windows or cars. There are a lot of places where you could think you might want to be able to harvest energy from sunlight, and then on demand trigger it to release as heat. Cool.
And do you have the other one in your head? I'm sorry. We can also, follow up with it.
Was, let me think, was it a battery technology? This was the one where I was very awkwardly trying to figure out a way to get to know the people in the lab with no class or other kind of cover story to make it a little less awkward. Like the iTeams class and Energy Ventures class are just wonderful because they create this low risk way of getting to know each other. Whereas if you're just an MBA student knocking on the door of a lab, there's immediately a little bit of mistrust, I would say.
Right.
Where the grad students and maybe even the PI might be thinking, what are this person's real motives? Do they want to steal our technology?
Right. Yeah, I wonder what the solution is. I wonder what the solution is to that. To stimulate entrepreneurs to come knocking on these doors and not be, met with skepticism, I guess, from the scientists that are inventing this stuff.
I think it's exactly what MIT has done so well and what Berkeley has done pretty well too, which is creating these low risk environments where MBA students and technologists can get to know each other. Because if your first conversation is, hey, want to start a company together, that's pretty high risk. If your first conversation is, hey, want to put your technology in a class and we'll have some students just work on the idea of commercializing it for one semester, that's much lower risk.
Right.
And MIT in particular has this great kind of step ladder of programs that they create to enable those low risk interactions. So they have a bunch of these classes, not just energy ventures, but I think they have a healthcare ventures one. They kind of have one for each
sector,
arena, each sector, yeah. And then they have the MIT 100K business plan competition, as well as the MIT Clean Energy Prize business competition. And that's another low risk way of getting to know people. So in our case, after finishing the class, I asked the 2 grad students who were clearly kind of the lead inventors on the technology, whether they would be open to applying to the MIT Clean Energy Prize with me. And this, at this point, they knew me a little bit. We'd had a few phone calls together, but we still didn't feel like a team. The 3 of us hadn't worked together in any close way. And applying for the Clean Energy Prize together was great, because once we made it to the semifinals, we got assigned 3 mentors who are from the semiconductor and optical communications industry. So first, we learned a lot from them, but secondly, and most importantly, they worked closely with us to help hone our pitch and make it better. And that was when the 3 of us, me plus these 2 PhD students, started really feeling like a team, and like we were working, the 3 of us, on starting a company. So I didn't, at that point, I didn't even have to ask either of them if they wanted to start a company with me. All I had asked was whether they wanted to, throw our hat in the ring for this business plan competition, just to see whether we even make it to the semifinals. So it was another very low risk way of getting to know each other. By the time I asked them if they wanted to start a company together, we had been working very closely together with these 3 mentors for a few months. And so it just wasn't this big risky thing. We knew each other pretty well at that point. We liked each other. We worked well together. So I really think that the whole ecosystem MIT has created for that step ladder of getting to know each other is really crucial to being able to spin technologies out of labs.
Yeah. And in the future days of potential Zoom learning, or I don't know, I mean, all that might be lost, or it might be an opportunity, I guess, to try to recreate it.
I neglected to mention that this technology actually was developed in a massive collaboration between 3 universities. So it was not just Rajiv Ram at MIT inventing this. He was collaborating with Miloš Popovich's lab at University of Colorado Boulder and Vladimir Stojanovich's lab at UC Berkeley. Now, this is pretty rare in the academic arena, that researchers across the country from each other collaborate and work together so closely to develop such a breakthrough. But this was very much a deep collaboration between the 3 labs. And the 2 PhD students who I applied for the MIT Clean Energy Prize with were actually based out of Boulder and out of Berkeley. So we never even met each other in person until pretty late on.
It was a person.
The one at Boulder had come to MIT as a visiting researcher, so I think I met him during the semester. The one at Berkeley, I might not have even met, I don't think, until we were applying for the finals of the business plan competition. He flew out for that, as well as to defend his thesis, because his professor at Berkeley had been a professor at MIT, had transferred out to Berkeley. My co-founder had followed him, but kept his degree from MIT. So he had to fly back to MIT to defend his thesis. And he did that in, I think, like the same week or 2 when we competed in the finals for that business plan competition. And that was really the first time the 3 of us were all together. So
those are people from the lab. Those are people from the lab.
Those are people from the lab. Yeah.
I'm saying from the labs of the co-researchers of your MIT professor.
Yes, except neither of them were in actually the lab of the MIT PI who I originally met. They were in the labs of the other 2 PIs on this project.
Got it. Very cool.
But yeah, going back to Zoom and this world of remote learning, I think it's absolutely possible to do all of this remotely, because we did it. We were across the country from each other, literally, when we did all of this.
Excellent. Well, that's inspiring. And so you were looking at this with these people in your class, and ultimately, I guess it kind of fizzled out, or you developed this, kind of commercialization pathway and plan or whatever, and then you pressed on with it and ended up engaging with these other PhDs and forming this company.
That's right. And to give a little more detail there, everyone in my team in this class were absolutely fantastic, and we made a wonderful amount of progress on the business concepts during the class. At the end of the semester, I asked each of them whether they wanted to keep working on this technology. I told them, I'm pretty excited about this. I want to see where we can take it. And each of them bowed out for different reasons. You know, the engineers each said, you know, I think this is super cool, but I'm not the engineer who invented this. I don't see a role for myself in this company. The business school students each had their own different efforts they were wanting to focus on. One actually started another company called Rapid SOS. His name is Michael Martin. And it's funny because we ended up winning the MIT Clean Energy Prize. And at the same time, Michael Martin with Rapid SOS won the MIT 100K business flight competition. And he ended up starting Rapid SOS, and that company is alive and thriving today in an amazing way. They provide a lot of the back-end technology that you use when you dial 911. They kind of modernize the 911 system, which is amazing to me that two startups ended up coming out of this group of students. But I was the only one who was interested in continuing to pursue this after the class was over. So, you know, there was one who continued with me, the policy person, Sergio. He continued with me for about a month, over the month of January. And then he realized, you know what, I want to work on this other startup idea that I'm working on with a friend. So, cool. So it ended up just being me, and I was still having phone calls with Mark and Chen, who ended up being my co-founders. We were calling potential customers, people in the industry, trying to learn, you know, even more about where there could be product market fit. And then at the end of January, I asked them if they wanted to do the Clean Energy Prize.
And when you're calling these industry partners, because I think that I want to drill down on that a little bit. I mean, can you talk about the importance of engaging with industry, how to do it, who you called? Maybe a little bit about that in terms of assessing technology, and also the importance of it in general in startup formation.
It is all important. I would say it's the number one most important thing in starting a company. And this is, I think, a big reason why going back to what I was saying at the beginning, it's oftentimes hard for inventors of technologies to play the entrepreneurial role. I think something that my co-founders probably valued at the time was that I was willing to just pick up the phone and make phone calls to people I had never met, and send emails to people I had never met, and follow up and be proactive, and then have these random phone calls, which it's kind of like a sales job, or, you know, you have to expect to hear no a lot of the time, and have people, you know, you never know what you're going to get when you're calling random people. I had no connections in the semiconductor industry, so I was combing the MIT alumni databases. I was really leaning on the mentors that were assigned to us with the Clean Energy Prize. There's also an MIT Venture Network group that we joined as a startup. You can kind of join this group, and they assign you mentors from the MIT community. So we were really leaning on every resource that we had available to us to try to make connections in the semiconductor industry, in the supercomputer industry.
And what would you do with these connections? I mean, what you were doing, sort of customer validation, learning about the industry?
We'd try to learn what problems they had that we could solve. And, you know, at MIT, they teach entrepreneurship using this book that Bill Aulett, the director of the Entrepreneurship Center there, wrote, called Disciplined Entrepreneurship. It's a great, easy read. And it very much teaches you that you have to, you know, the most important thing is finding a customer and getting customer validation for what you're doing. So we were following that methodology, but there are a lot, you know, the lean startup methodology is another one. There are a lot of different approaches that essentially teach the same thing, which is talk to as many people as you can to learn, you know, what's a really important problem that they have that you can solve. And for us, it was a little more detailed than that, because, you know, we knew that there was this imminent kind of bottleneck approaching in the semiconductor industry of electrical communications. just not cutting it, not being enough to move data between chips. Because as Moore's law has been really successful in growing exponentially how much computing power you could fit on a chip, we haven't seen that exponential growth in how you move data between chips. And so it was a well understood problem that moving data between chips is a bottleneck, but understanding where can we fit in that industry. So we've made a processor, and at this point, I think they were starting to get results back that they had made a processor that communicates using light. They hadn't published it yet, which would come later, but they were just starting to test the chips that were some of the first processor chips to communicate using light, which was very exciting. And so, okay, we have a processor that communicates using light. What do you do with it? Do you make a supercomputer yourself, where you're making a processor trying to compete with Intel, and maybe making a GPU trying to compete with NVIDIA, and then having optical communications between all of these chips? Or at the other extreme, do you make an optical transceiver, which is, do you just make the optical cord that connects different components of the machine? And there are optical transceivers out there. They tend to be pretty big, bulky, and power hungry. Do we make a smaller, less power hungry version of an optical transceiver? And then there was kind of everything in between. So it was really figuring out, what's the product that we're making? Sure, we have this technology, but where should it fit, and where can we actually create a business that has staying power and that can really create the transformation we want to see in the world?
Right.
And that was a really tough question to answer.
Yeah, it's interesting to have a solution and at the same time be searching for a problem that will then, refine your solution and into addressing those problems. I mean, so were the first problems that you discovered the ones that you started to, kind of iterate towards and adjust to?
The pitch we gave at the MIT Clean Energy Prize was that that high-speed traders, the people on Wall Street,
right,
who they call themselves market makers. They're placing trades super, super quickly and beating everyone else to it. That these people would be our initial, what's called beachhead market in the terminology that that they teach for entrepreneurship at MIT. So, you want early adopters who really, really, really want your technology. And you want it to be a pretty small market, but one that just has a huge need for what you're doing. And then once you've successfully delivered to those early adopters, then you expand out to other markets. And that's where the kind of big market opportunity can be. So our beachhead market in that pitch was these high-speed traders. And we said, they make so much money, they'll pay anything for that millisecond faster of data to be able to make their trades, because they make so much money doing that. So they'll fund our initial products, and then we'll branch out into broader data centers. So that did not remotely end up being what we did with Ayar Labs, but it did win us the business plan competition, which was very helpful. Because it gave us a lot of validation winning that business plan competition. I think it made my co-founders feel confident in starting a company rather than going and getting hired by big semiconductor companies that were trying to recruit them, because all these smart people had told us that there was something here.
Right, and you can feel it when
and we got some money.
Yeah,
and we got $275,000 for free, no strings attached, and that helped us, go out and start the company and not have to fundraise from venture capital investors immediately to be able to pay ourselves salary, but to be able to take some time and really figure out what we were doing before we had to go out and start pitching VCs.
And had you licensed the technology formally yet? Can you talk a little bit about that process and when you did it and how you found it and some of the terms and all that kind of stuff, whatever you feel comfortable sharing?
Yeah, so a good thing about the MIT Clean Energy Prize structure is that they require you to, number one, incorporate prior to the finals. So you don't have to actually be incorporated. Ooh, hang that up. Oh, I apologize. Can you hear that on your end?
Yeah, it's okay.
There we go. So you don't actually have to be incorporated to apply for the prize. They make it a very low barrier to applying. It's just you submit a pitch deck. But if you want to compete in the finals, if you make it to the semifinals and want to compete in the finals, you have to be incorporated, and you have to have ownership of the technology. So they kind of put this deadline on licensing and on incorporating, which is very good when you're kind of in these early stages of company formation. So what we ended up doing was we did approach the MIT Technology Licensing Office there. It's called the TLO. Oftentimes in other places, it's the TTO, Technology Transfer Office. But we approached the Technology Licensing Office. We told them we were interested in the technology. At MIT, they do prioritize licensing technology to its inventors. So that was nice. They kind of took us seriously, and they were interested in us licensing it because we were the inventors.
What do you mean you were the inventors? Because the two of the PhD students were from the labs that had collaborated on this invention.
That's right. Their names were on the inventions, as well as Rajiv Ram,
who was an advisor.
The PI,
right.
Yeah, who was the PI in the lab that had developed all of these, there's a dozen patents that had been developed over the past 10 years. It was Rajiv who was reaching out to the Technology Licensing Office, introducing me to them.
Right.
So that is the best way to get an introduction to a technology licensing office when you want to license something, because they only want to license to people who are going to be actively working to commercialize the technology. They're very, at MIT at least, and I imagine this is probably true for a lot of them, they're very wary of licensing to patent trolls, people who are going to license a patent and then just go out and sue others for infringing on it.
Right.
So it's very good to get that introduction through the PI, the inventor. Because this was such a big portfolio, this wasn't a single patent we wanted to license. It was a dozen patents. And because, all of those 3 PIs that were spread across the country from each other, they had all started out at MIT collaborating, and over the decade, 2 of them had ended up taking positions at other universities. But one of them had ended up continuing to invent technologies at the other one, at CU Boulder. So a bunch of the patents were co-owned by MIT and CU Boulder, which added a layer of complexity. So overall, my experience in licensing was way more complicated than most people's experience licensing will be. But because of all of that, and because we just wanted to get something in place prior to the finals of the business plan competition, we ended up doing what's called an option, an exclusive option to the exclusive license to the portfolio of technology. So it meant that we could pay a very nominal amount. I forget, it was $500 or $1,000. It wasn't that much at all to get exclusivity on this portfolio. And it kind of started a timeline. We then had 1 year to actually negotiate a full license of the technologies. What happened during that year was, in the first 6 months, we didn't do anything because MIT and CU Boulder were busy negotiating a joint invention agreement between them. And that took over 6 months for them to just agree on the terms, by which then I could just negotiate directly with MIT on behalf of the entire portfolio, and I wouldn't have to do a separate licensing agreement with CU Boulder. So we had that 1 year timeline, and we also had a 6-month extension period. So if it ended up taking longer than a year for us to negotiate the full license, we could extend up to an additional 6 months. We ended up using the entire 18 months to finally get the full license in place. So yeah, more than 6 months was used on the joint invention agreements for the patents that were co-owned, and then
but even then it took a year. How can this be improved?
I don't know if it's something that can just be automated or done. The reason it took so long was because MIT has their standard form of technology licensing agreement that you start out with, right? And then you're negotiating terms on that. But the standards for how much you pay for royalty fees And if you're a startup, typically you can trade off royalty fees for equity in the company. And that is, they have that standard form of agreement, which is great. But even given that, how much you're willing to pay for royalties will really vary depending on what industry you're going into. So the standard form, there's no standard form that can just work across industries and technologies, et cetera.
But so, they could standardize the equity. They could standardize it in the form of equity as opposed to.
They do. Yeah. So, I mean, I think if you could convince a technology licensing office to have a standard form where they just take a certain amount of equity and that's it, that would be amazing. It would save so much in lawyer time, et cetera. And it would very well align incentives for the company to be successful. Another thing that there are a lot of terms in the licensing agreement to do with actively working to license to commercialize the technology. So basically, they'll put milestones in there where like, oh, you have to make your first sale by this date and, be in mass production by that date, because they want to make sure you're proactively working to commercialize the technology. And if your company ends up taking a pivot or doing something a little different where you're not actively trying to commercialize the technology that you licensed, they want you to release it back to them so they can license it to somebody else. So, I think they could bake all of those terms in and make it just a pure equity agreement and really simplify things. That probably could be true. We ended up hiring a top-notch lawyer who really helped us with the negotiation, and I would say that was invaluable. Our lawyer had access to a database of other licensing agreements that his firm had negotiated both with MIT as well as with other universities. And so he knew very much what to expect as an outcome in terms of royalty rates. And he had very good tactics for bringing those rates way down. So
cool.
That would be my biggest advice in this world we're in, where we don't have some simple agreement that's standard that we can just sign. And if you're gonna have to go through this process, I would say it's worth finding kind of the top IP lawyer in your field to help you.
Cool. And after this whole process, you had some trickles of funding. I mean, what was the next tranche of funding that you went after that helped take you to the next level and in the process?
Yeah, so the first one was that $275K we got for free, which is amazing, from the business plan competition. Shortly thereafter, immediately a few weeks after, we applied for a Small Business Innovation Research Grant, SBIR, from the National Science Foundation, NSF. And so we got another few $100K from that. We applied right as we were graduating.
Was that difficult? I mean, can you talk about some tips and best practices for applying to that? Yeah.
There's this kind of national requirement, this federal requirement, that each agency within the federal government offer these Small Business Innovation Research Grants, SBIRs, which is fantastic because they are, intended for exactly this. But a little tidbit that's actually quite important to know is that the NSF, the National Science Foundation, was the first one to create this SBIR program. And back when they created it, it was really for exactly this purpose, to help small businesses form out of interesting research, help commercialize technology. So their program, their SBIR program, is quite broad. They're not looking for any specific technology to commercialize. If you're just working on an interesting technology you're trying to spin out of a lab, you're probably going to be a very good fit for an NSF-SBIR, and you should probably just apply and be as convincing as you can be in your write-up, but you'll probably qualify well. All of the other agencies, whether it be Department of Energy or Department of Defense or Health or whatever it is, they all are federally mandated to also have SBIR programs, because at some point Congress saw how successful the NSF-SBIR program was and said, hey, devote a portion of your annual budget, all of these other agencies, to SBIRs. But the way that these other agencies have implemented SBIRs is they create very specific calls for proposals where they're saying, I want this specific technology to be commercialized. And so you have to comb through all of these prompts that they have and find one that matches you. And if they are looking for your technology specifically, it could make sense to apply, but it's much more restrictive just for that reason, because all these other departments don't care as much about just enabling broad commercialization across all technologies. They care much more about, Department of Energy, they care much more about specific technology priorities they might have, and whether it's solar or batteries or whatever. And same goes for each of the other agencies. So my advice would be, if you're starting a company, just take advantage of the NSF-SBIR if you're in the US, and just apply, because you can probably get a few $100,000K. And that's free money. Yes, the strings that are attached are that you have to write a bunch of reports, but they don't take any equity the way investors do. So it's just a great resource to have. And then if you're successful in phase 1, then you can apply for phase 2, which comes out to $1 million, which can be really helpful. So, the first thing we did was apply for that NSF-SBIR, and we were granted that phase 1. We ended up going on to apply for a few DOE SBIRs later, and a bunch of Department of Defense grants as well. And it turns out we've gotten quite a lot of non-dilutive funding as a company now because of those things, but it took a little bit of extra level of maturity to get the DOE and DOD grants and relationships with program managers in those departments, where, in some cases we're even helping them craft the language that was the prompts asking for these proposals. And that's kind of what it takes to make sure that there are prompts that fit your technology.
That's an interesting piece of advice also. If you're going to go for the DOE, ARPA, DOD grants, whatever, make sure to build relationships with the program managers who are going to be reviewing your applications anyway. That's interesting.
Yes.
And what did you do with the SBIR NSF money?
We did our first.
Yeah, it was all research.
Ahead.
No, I mean, it was all geared towards research, or to furthering the research?
Yes, it was. We did our first chip tape out as a company. And for those not in the semiconductor industry, what a tape out is when you design a chip and then you send that design file to the manufacturer. So in semiconductor, it's most common these days for companies to outsource the manufacturing of chips, and companies just design them. And that's even true in university labs, where students or labs will design one portion of a bigger, what's called a chip reticle, and kind of tape out, send these designs over to get combined with other researcher designs and then taped out, because manufacturing is quite expensive to do by yourself. So they kind of pool resources. So anyway, we continued in that vein and taped out our first chip design as part of this multi-design chip manufacturing run. And we paid for that using that NSF-SBIR. And we also paid for some of our hours. All of us were kind of starving students / had just graduated and needed to be able to pay rent and for food and things. So we paid ourselves as well as paying for the manufacturing of that chip. The other thing is we paid for our first server because there wasn't any good solution. I think still to this day, there's no good cloud solution for designing chips. There are these tools you have to use for chip design that are quite expensive, and you kind of have to put them on your own server. So we bought a server and we taped out a chip. That's what we did.
Cool. And you're able to pay salaries with SBIR grants?
You are, yeah.
Very cool. So are there other tidbits, pieces of advice that you would give to young upstart entrepreneurs or grad students or researchers that might be listening, and in general, doesn't have to be too in the weeds, but any advice you would give?
I would say, well, I guess just to finish the timeline of fundraising quickly. So, we had the prize and the grant, and those were both great for giving us this buffer of time where we got to spend more time getting to know industry and finding product market fit. We ended up pivoting away from the idea of starting with that beachhead market of high frequency traders, and realizing that probably supercomputers and AI, machine learning, training in particular, were probably good first beachhead markets. And then it wasn't until we figured all that out that we started fundraising from venture capital investors. And so having that little runway where we could learn before we went out to fundraise, I think was really valuable for us, because we did feel like we knew much more what we were doing by the time we were going and giving VC pitches.
Yeah, and I like the continued emphasis on interaction with industry, and the continued evolution and learning in what to attack, what markets to attack. So that's
yeah, and I would say that is the most important thing in terms of advice. Advice for people who want to do this. So, whether it's you, if you're the technologist and you invented something you want to spin out, maybe you don't feel too comfortable getting on phone calls all day with people you don't know. And if you can find somebody else who maybe is more interested in doing that, maybe has more of a business background, so that's a great way to do it, or just push yourself to go do it. I think there are a bunch of companies where the technologists did it themselves. They went out on a limb and taught themselves to do very different things than they had spent the last few years doing in the lab. Either way works, but the important thing is to have a ton of customer conversations, because once you do go start trying to fundraise from venture capital investors, what they're going to want to see, great if you have this breakthrough technology. By the time we started fundraising, this breakthrough of the world's first processor to communicate using light had been published in Nature, this preeminent research journal that typically doesn't even publish semiconductor related things. But because it was such a big breakthrough, it got accepted into the journal Nature, which was a really big deal. We got a ton of press when that paper came out in December 2015. And then it wasn't until 2016, spring 2016, when we started fundraising. And despite all that, VCs don't really care about how cool the technology is if you can't show them that you have customers who are willing to pay for it. So that's where the customer conversations are really important. And let's say you do a killer first pitch to a VC. If they are really excited about you, their next question is going to be, who can I talk to? Who's a potential customer who wants to buy this thing? And they're going to want to get on the phone with that first customer. And so you need to have that lined up. And so that's where all those customer conversations are super important.
Yeah, amazing. It's cool to also hear about how the multiple year trajectory of those customer conversations and how they're important, on the long arc of all of this. So that's super inspiring. Is there advice that you would give to yourself, the younger version of Alex, that, that's something you would do differently or anything like that?
I would probably say don't bother knocking on the doors of random PIs, introducing yourself as an MBA and asking if you can help. It just, in retrospect, that I don't think that was ever going to work. And I would say just focus your time. If you're an entrepreneur trying to find a technology, focus your time on finding these low risk ways to engage with technologists, because building up that mutual trust is the most important thing.
Okay, excellent. Well, I think that's a great place to stop. Alex, thank you so much for joining. Is there a place that people can find you? I know you're on Twitter and LinkedIn. What do you prefer? Where do you like people to reach out?
Yeah, both are great. Twitter and LinkedIn. On Twitter, you'll probably post this in the show notes, but it's Galax, where the L is a 1. And on LinkedIn, I'm Alex Wright-Gladstein.
Cool. Well, Alex, thank you so much for joining. People feel free to visit bountiful.org for more, catch our other episodes, and I'll put everything in the show notes. Thanks for joining us. Alex, thanks again for joining.
Thanks so much for having me, Max.
Thanks for listening. But now we need your help. We're building a community of scientists, students, entrepreneurs, industry leaders, and investors to commercialize meaningful technology and research. Join us at bountiful.org today to find opportunities and realize your power to save the world.